Hello friends, in this video we will learn about how to calculate power when force and velocity is given. So let us see this problem. So this problem says each of the four jet engines on an Airbus A380 airliner develops a thrust, that is a forward force on the airliner of 322,000 Newton. So this is A380 airliner. So this is the airplane and the model of this airplane is A380. And this airplane has four jet engines. So this is the first jet engine, the second one, third one and the fourth jet engine. The question says each jet engine basically develops a thrust and the magnitude of thrust force is given, that is 322 kilonewton. So we have been given magnitude of thrust, that is, let's call this as a F. Magnitude of thrust is 322 kilonewton. Now this force will act in the forward direction. So question also says this force is acting in the forward direction, which is basically a forward force on the airliner. So on this airplane a forward force is acting and the magnitude is given and the direction is also given. Now next part of the question says when the airplane is flying at a speed of 250 meters per second. So in this case a speed of airplane is given and that is nothing but magnitude of velocity, and that is 250 meters per second. So this airplane is moving in this direction and the thrust is also applied in this direction. So both the thrust force and the motion are in the same direction. So we can say angle between force vector and velocity vector is 0 degree. So we can say, and we will use this. So angle between force vector and velocity vector is basically 0 degree. So now question says what horsepower does each engine develops? So basically we have to find the amount of horsepower developed or generated by each of the engine. Now you may remember horsepower is a unit of power. So in other words, we have to calculate how much power each engine develops. So basically we have to find in this problem power developed by each engine. So power developed by each engine. So you may remember what is the formula to calculate power. So power is basically F dot V. This is the dot product. So if you take dot product of two quantity, it becomes a scalar quantity, and that's why in this case force is a vector quantity, velocity is a vector quantity, but once you take the dot product, the power becomes a scalar quantity. So power is a scalar quantity in this case. Now F dot V I can write magnitude of F, magnitude of V, and then I have to multiply by cos phi, where phi is the angle between force and velocity vector. In this case, the angle between force and velocity vector is 0 degree. So cos phi is basically cos 0, which is equals to 1. So I can simply write this is nothing but F, magnitude of F multiplied by magnitude of V. So now I know magnitude of F. This is nothing but 322 kilonewton, that is 3.22 into 10 to the power 5 Newton. And then I have to multiply this with the velocity, magnitude of velocity, that is nothing but 250 meter per second. So if you do all this calculation, you will find this turns out to be 8.05 into 10 to the power 7 into watt. So basically this is 8.05 into 10 to the power 7 watt. So that is the SI unit of power. Now the question says you have to calculate the power in horsepower. So you see what horsepower does each engine generates or each engine develops? So you may remember 1 horsepower is equals to how much? This is equals to 746 watt. So now I can use this conversion factor, that is 1 horsepower is equals to 760 watt, and we can find power in horsepower. So power was 8.05 into 10 to the power 7 watt. And then if I divide this by 746 watt, and then horsepower will go on the top. So if you calculate all this, this will come 108,000 horsepower. So around 108 kilo horsepower. So this is the power that is generated by each of the airplane, each of the jet engine. So if you consider the total power generated by all the jet engines, then you have to multiply by 4. But for in this case, we have to calculate power generated by each of the engine. So this is the amount that is generated by each engine. Now see, the thrust force is directly proportional to velocity. If you increase the velocity, the power, the generated power or thrust force will increase. So a speed is directly related to power, because power is equals to F dot V. So you see in this case, this is because angle is 0 degree. So simply F into V. So power is directly related to velocity. In other words, if you want to increase the velocity of airplane, in that case you have to increase the power of jet engines. You may have to have 5 engines or 6 engines, so depending upon, or you may have a one engine which generates more horsepower. So if you want to increase the speed, then you have to basically increase the power of the engine. And this is a fact that largest propeller driven airliner in around 1950s had engines that developed about 3,400 horsepower and giving them a maximum speed of 600 km per hour. So this is a fact that is the older airplane generally used to have a speed of 600 km per hour, and the power developed in those cases is around 3,400 horsepower. So compared to this problem, in this case you see this power is around 108 kilo horsepower. In this case this is very less, that is around 3.4 kilo horsepower. So these days we are having very high power generated by the engines, and that's why a speed of the airplane is much larger than the older airplanes that used to having a speed of around 600 or 700 km per hour. I hope you like this video, and please like and subscribe this video, and I will see you in the next video. Thank you.